In the previous lesson, we learned about Acme and their current pain points and their plans for a new system. We discovered the 5 goals for their project and we uncovered the rationale behind those goals. In this lesson, we want to talk about how those goals impact the decisions that we'll be making as we begin to formulate a candidate architecture. So at this point, all of our discussions should share 2 traits. First of all, that they're at a very high level, and secondly, we understand that we do not want to be set in stone with anything we talk about in this lesson. What I really want to do is just examine the goals from the previous lesson and talk about the way in which they'll impact our architectural choices, being flexible enough so that in the future we're not tied to these or married to these decisions. All right, so first of all, the first goal was to support Acme's new sales and maintenance business process. This suggests that the core of the system is the problem domain, locating the parts and creating an order and all the business rules around that. As I said in the previous lesson, we're going to have to flesh out those business rules around the business processes in a series of user stories, which we'll talk about in the next lesson. However, we did identify the fact that there may be a lot of business rules related to who can create an order, how we find parts, reorder levels, and things of that nature. What was clear to me was that getting those rules right will ultimately spell the success or the failure of the project. So how does this impact our architectural decisions? Well, knowing that there are many business rules and that this system will be supporting a brand new business process moves me closer to deciding that we should focus our effort on allowing the domain layer to drive the development process. We want to get clear on the domain layer because it will be the model of the business going forward. The second goal was to create a solid code base that can be maintained and will be responsive to new business opportunities. This goal suggests that Acme is concerned with code quality. They're concerned with maintenance, that they want to have the confidence to make changes to the code base in the future. There will be a number of decisions that will need to be made regarding creating a maintenance team that's regimented in how it adds and deploys new features, how it versions the source code, how it creates a code review process, and so on. There will need to be some architectural decisions made up front by you and I that would facilitate a healthy code base that can be modified in confidence. So how does this goal impact our architectural decisions? Well, knowing that the client wants to ensure maintainability, that pushes me closer towards utilizing unit tests. Now, this doesn't necessarily mean that unit tests should drive the process, although I may prefer that for other reasons. I'm thinking that a solid architecture coupled with a set of unit tests could be handed over to a maintenance team, and they'd be able to quickly ascertain the purpose and the intent of each method and each class in the system. It'll also help as they go to make changes. If they're not already familiar with the code base, they don't know what they might be breaking by making changes. So a good collection of unit tests should warn them and immediately call their attention to the impact that their changes just made. So this seems like an easy decision for me personally, that this goal is coupled with unit tests. All right. So the third goal was to unify the processes and data across all Acme subsidiaries across the world. If you recall, the idea here was to get the other subsidiaries to sign on to this new system. Not only would they help create a more integrated organization, but in the short term, it would help justify the expenditure as our stakeholders attempt to sell this or promote this application internally. So the main areas impacted by this were, first of all, multiple language support, and secondly, existing persistence technology commitments. Remember, we need to support both SQL Server, Oracle, and perhaps cloud-based architectures in the future. So how does this impact our architectural decisions? Well, automatically I'm leaning on any project, before I even hear what the requirements are, I'm already leaning towards a layered architecture. Even if all the layers are in a single project, and even if all the layers are anemic, meaning that they don't do a whole lot, they're there due to a formality, not because they necessarily add a lot of value. I'm still committed to at least thinking about every project in terms of layers. So this goal just reinforces that I'll have at least 3 layers: a presentation layer, a domain layer, and a persistence layer. And furthermore, this goal reinforces that what I'm already inclined to design into this system, namely that the layers should be completely abstracted away from one another. In other words, I want to seek to separate the concerns, and I'll do so using the tools that I have at my disposal, like C# interfaces and dependency injection. I don't want to couple my domain layer to SQL Server or Oracle because I know I'm going to need to swap those out. I don't want to couple my domain layer to English or German or Japanese or whatever the case may be because I may need to swap those out. Now, admittedly, there are ASP.NET specific ways to handle globalization, what some people refer to as just using different language versions. All right, there are specific ways to handle that in the both the persistence layer, but I was really thinking about the presentation layer. However, it occurs to me that other parts of the system might be impacted by this need as well. For example, reporting, which is not in scope for this phase of the project, but I have to, as an architect, have a little bit of foresight and do a little bit of forward thinking. And that means the requirement potentially for reporting means that I want to pay special attention to the storage of the data, to the handling and the presentation of date values, money values, and the like. All right. So again, what this does for me, this particular goal, is that it reinforces the need for not only layers, but then also the separation of those layers using interfaces if possible. All right, then the fourth goal was to centralize the data to allow for better analysis, tracking, and reporting across the entire supply chain. So we learned that the stakeholders were already thinking in terms of a centralized database and a web-based user interface with other potential native clients to be made available in the future for like iOS, Android, Windows Phone 8, and so on. It's not uncommon for clients to have a strong opinion about the presentation layer. Everybody thinks they're a user interface design expert. As the expression goes, let the baby have his bottle. That might be a little bit pejorative in this context, but ultimately the design of the user interfaces is a small thing. It's something that the client will have to work with every day. They're going to have to live with it, and honestly, I could care less what the user interface looks like. As long as I feel like my other design goals are being met, I'm fine with that. And by design, I mean I want to make sure that the code is it's able to be changed, that it's robust, that it has a set of unit tests surrounding it, and so forth. Those are the things that are important to me now. Earlier in my career, I was very interested in the aesthetics of things, but you know what? Those things will take care of themselves. The users will have their input, and they will drive some of those design decisions, and they're kind of out of our hands, honestly. But more importantly, how does a centralized data store and a web-based UI with the possibility of native clients impact our architectural decisions? Well, to me, it continues to reinforce the need for a layered approach. The layers themselves do not change, but now I begin to think about their deployment. This is shaping up to be physically deployed in a single location, accessible via a web browser. While I don't want to necessarily make any decisions that will back me into a corner, I start to think about things like authentication and authorization over the public internet as opposed to Windows authentication on a local network. Whether I'm going to use ASP.NET MVC or web forms. Will I rely on a more traditional interaction between the web server and the web client, or will I opt for an emerging set of a single page application JavaScript libraries? While I may not have included a web services layer in my initial thoughts of the solution, I begin to consider how that might be useful in supplying native client applications like iOS, Android, and so forth with the data that they need to display and accept data. Perhaps it could be useful in a single page application SPA scenario as well. Finally, the auditing requirement is somewhat troublesome because of the potential performance impact it has on the system. So just think, every time that we touch the database on behalf of the user, we have to formulate a message, and then we have to save it somewhere. The sheer amount of data that we're going to be collecting and saving can be mind-boggling. Also, I'd like to just be able to fire and forget and not have that operation of assembling the message and then waiting for it to save block the performance or the execution of my application. And I suppose that we could rely on features that are built into our data storage persistence tool like SQL Server or Oracle. I think they both have features that will allow for this type of auditing. However, is that really a cross-platform solution? By delegating that responsibility to one of these vendor-specific tools, we're going to be tying the business to that tool forever, or at least until the next time that this app is rewritten. And so I shudder at that. That doesn't sound palatable to me. I don't know all the answers, but this is a big constraint on the system, and it definitely impacts my architectural decisions. At a minimum, I would want to keep this part of the system decoupled so I could change my mind in the future. I don't like any of my options, and that means I don't want to tie my solution to a single option for all eternity, right? And then secondly, my own biases push me towards using Microsoft Azure. Specifically Azure Queues for the fire and forget aspect that queues afford us, and then use a series of worker processes to grab the audit messages off the queues, format them appropriately or validate them or whatever, and then write them into a more appropriate permanent storage. I would probably be choosing Azure Blobs or Tables for that permanent storage part. I think I'd want to avoid Azure SQL Server because I don't need the relational database capabilities that it gives me. But honestly, at this stage, I'm probably drilling down too much. In the back of my mind, I want to think to myself why an Azure-based auditing solution wouldn't work, keeping it appropriately decoupled, of course. But it seems to have a lot of the characteristics of what I would need to solve this type of problem. All right, so what did we accomplish? Well, the purpose of this lesson was to talk through the impact of the goals, the requirements, and the constraints of the project on our architectural thinking. As you and I collaborate on the requirements in the next few lessons, we start drawing diagrams and having discussions at the whiteboard about what a system should look like conceptually at a high level. We agree to defer technology decisions as long as possible. It's really too early to talk about which presentation technology and which persistence technology that we're going to implement for the first and subsequent versions of the app. Nonetheless, it's already begun to creep into our thinking, right? I suspect we already know the answers to some of these questions in the backs of our minds, but let's pretend for now like we don't really care to think about them. That liberates us from focusing on the technology stuff to rather focus on the part of the system that really matters. We agree to focus on the problem domain first. So as architects on this project, you and I need to start diving deeper into the detailed requirements of the system. That means we'll need to review any user stories or actually just any requirements that Acme's business analysts have already created. Worst case scenario, you and I have to create those ourselves, right? So remember from the previous series, or from the previous lesson, user stories are simply agile descriptions of tasks that users should be able to perform within our system. These will lead us to discovering much more detail about the problem domain. You'll learn how these flexible little tools, these user stories, will be leveraged throughout the planning, the estimating, the analysis, the development process. They're really handy. And while I don't plan on talking about user stories or agile estimating and planning and project management and things of that nature in this series, I will be talking about those sorts of things, agile software development and Visual Studio Team Services, in a dedicated mini-series. So when it's available on learnvisualstudio.net, you can see the huge role that user stories play in our project. For now, we're mainly going to use them to help drive the development of our architectural spike, which we'll begin talking about in the very next lesson. We'll see you there. Thank you.